Okay, here's a QuickTime recording and screen capture of using the dtmf detection template for the dtmf project that I've assigned to you. Alright, so if you download this and open it, let's go through what you need to do to modify it to make this work. Alright, so the first thing we're doing here is we're reading in an audio file into a vector X, and you'll of course also capture the sampling rate for the audio. Alright, next you're going to need a threshold T, and we'll talk about how to adjust that. This current value right now won't work, so you'll have to adjust that to make that work. Next on the list, we're taking a 1024 point FFT for this project. You could use other values and this would work, but this is a standard value. We're going to go with that. Alright, the first thing you're going to need to do beyond adjusting the threshold is also to give the frequencies for the low group of a dtmf signal and also for the high group of a dtmf signal. So you can Google that and find those values, but basically you're going to put in 4 numbers. These aren't the correct 4 numbers, but this gives you an idea of what the format looks like. For the high frequency group, you're going to do the same thing. Put in the correct numbers. Alright, and that gives you the critical frequencies that we'll be looking for with the FFT. But we've talked about this. The FFT, there's frequency values in hertz, but there's also K values, the index values that come out of the FFT. So really what we're going to be doing is we're going to be searching the FFT over the K values. Alright, so that means we're going to need to convert FL, the low frequency group, to a KL. Alright, so you have the 4 values in hertz. You need these to be converted to the 4 values in integers. Alright, so in index values. Alright, so there's a formula for that. Alright, you can apply the formula. The formula involves the FFT length, the sample rate value, and each of these vector components. Alright, so we've talked about that in class. The other thing I need to warn you about is that Matlab starts indexing at 1 instead of 0, which means you're going to need to add 1 to that formula that we've used for converting F values to K values. Alright, so at this point you've got the K values, and next what we do is we set up a way of decoding the rows and the columns on a dtmf signal. So this is just an array. We're going to use this array a little bit later, but for example, if I had row 1, column 1, that corresponds to the number 1 on the keypad. Down here, if I took row 3, column 1, that would correspond to 7 on the keypad. And as a final example, row 4, column 2 corresponds to 0 on the keypad. So the other, like the pound and the star key, I just put those to numerical values because I didn't want to mess with character strings in this code. Okay, next we skipped this part so far about the threshold T, and so we're ready to talk about that at this point. So in class we'd mentioned that you need to do some kind of mechanism to find where the digits are in the time domain. Okay, so we're pressing these dtmf digits. At what time values do they occur? Alright, so what we discussed in class was doing a moving average filter to look for the energy of the signal. Alright, so I'm taking the signal and I'm squaring every component. Alright, the reason I need to square it is I'm looking for the energy. I don't want positive values and negative values to cancel, so I square everything. Alright, then I set up something for a moving average filter. This is just a vector of 1s that's 64 in length. Alright, so when I apply this filter command on the squared signal, alright, I'm taking a moving average filter over the instantaneous energy values of the signal. Okay, when I do that, I can plot this signal, and I get this look over here on the figure 1 plot. Alright, so this is a 10-digit phone number. Some of the test files that I give you are only 7-digit numbers. All right, so you can see here's digit 1, digit 2, digit 3, digit 4, 5, 6, 7, 8, 9, and 10. All right, so this tells us where these occur in time. All right, so what I need to do next is I need to come up with a way of figuring out where, where exactly does a digit start and where does it end. All right, so one way to think of this is you want to detect this rising edge, and then you also want to detect this falling edge. If I knew when in time the rising edge occurred and when in time the falling edge occurred, the data that I need to take the FFT of is simply the values in between those 2 points. Okay. All right, so I want you to understand this code that I've written to make this happen. To detect an edge, we compare to a threshold. So I have this if statement, if y of k is greater than t. All right, but I need to know whether I'm looking for a rising edge or a falling edge. So if the R flag is set to 0, that means I'm looking for a rising edge. So if both things are true, then I'm going to detect a rise, and so the first rise, right? I'm counting the number of rises. So the first rise occurs at time index value k. All right. Once I detect a rise, I set the R flag to 1, meaning the next thing I'm going to look for is a falling edge. Okay. Once I detect a rising edge, I'm not looking for that anymore. I'm looking for the next thing that's going to show me a falling edge. All right, so this code does that. If I'm looking for a falling edge, I have the R flag set to 1, all right, and if y of k is less than the threshold, all right, so I'm going along here, here's the energy. When the energy drops down below a threshold, I've detected a falling edge, and so I keep track of the time value k where that falling edge occurred. So keep in mind right now, C and T is equal to 1. I'm counting rising edges and their corresponding falling edges. All right. So by the time I reach this point in the code, I've detected the first rising edge and the first falling edge, and now I can increment this counter, and at the end, the variables rise and fall have the time indexes for where the signal exists, where each of the digits are being pressed. Okay, hopefully that makes sense to you. All right, so now that I have that located, it's just a matter of applying the FFT. All right. However, there's a possibility that I get a really short glitch here, and I would have a false detect where I don't really have a digit. It depends on how noisy the signal would be. This signal is clean enough to where that probably wouldn't happen, but let's take care of that. All right, so if I look at fall of m minus rise of m, remember m is just going through all the rising edges and all the falling edges. All right. If I look at that difference, that tells me how long in time each of these pulses last. All right, so what I'm saying here is for this to count, it has to be more than 300 samples. If it's not more than 300 samples, I'm saying there's not really enough energy there to detect a digit. All right, 300, that's just a number I came up with by kind of eyeballing things and knowing that all these digits have much more than 300 samples in it. All right, next, I know about Matlab indices, so I'm taking the FFT of the signal between the rising edge and the falling edge for each m value. All right, so I'm essentially going through all the digits with this loop. All right, the next thing I'm doing is I'm looking at the FFT. Remember, cap x is the FFT. I'm looking just over the KL index values. So KL, if you remember, is a length 4 vector. All right, so I'm looking up what is the FFT value of the magnitude of x. Okay, I got ABS in there twice. I didn't need that, but oh well, it still works. Okay, the max over the 4 k values. All right, and I don't really need to know the actual maximum. What I need to know is where it occurs. All right, so if it occurred at the first k value, that would mean that would be at row 1. If it occurred at the second k value, that would be row 2. All right, so the max function gives you both the true maximum that's coming out of the max function and also the index value where the maximum occurred. All right, so it's these index values that I care about. Here I've searched over KL and got the row number. Here I search over KH and get the column number. All right. Well, that does it for me because I have this number array. So if I plug in the row value and the column value, that gives me the digit that I've dialed. All right. So this variable is just concatenating the phone numbers as I decode them one by one in this loop. All right. So by the time that all runs, I have my phone number, and this particular line will just display that in the Matlab command window. All right, so hopefully that you understand what's going on with this. Please take the time to make sure that you understand what's going on. All right, what you have to do is adjust this threshold value. You see why 20 won't work? 20 is way beyond 18. I'm looking for rising edges that exceed 20. I wouldn't detect any if cap T is 20. Would it work if I set it to 14? Well, it would catch this one. It would catch this one really strong tone in the middle, but it would miss some of these weaker ones. So you need to adjust this threshold where it detects all 10 digits. All right. Also, in summary, you need to adjust these to the true low frequency values that you can find by researching dtmf signals. Set these to the high frequency values. All right. Convert those to index values, and you should be able to run the code and decode these signals. All right. So I give you 3 example files to decode, and so just do that and answer the quiz, and you'll be done with this project.